All right, now we move into the second half of Chapter 3. This is Section 3.5, which you can find on pages 162 to 164 in your book. And we're going to be writing ratios and proportions. Your objective, obviously, is going to be to write ratios and solve proportions. And this is actually going to be the next two sections. We're going to do some basic stuff that you probably have done a little bit in the past. And then next section, we're going to take it one step further, like we always seem to do. So, just a quick little review. All right? A ratio is just a way of using division to compare numbers. There are three different ways that you can write ratios. So why don't you write this down, please? All right? So we can write the ratio A to B using the colon that you see, A to B using the word to, T-O, so A to B, or writing it as a fraction, A over B. And each of these ratios mean the ratio of A to B. When we use numbers, ratios are always written in lowest terms. So here's our first example. There's a volleyball team that plays 14 matches at home and 10 matches away. So the two questions we're going to answer are these. First, what's the ratio of home matches to away matches? And second, what's the ratio of home matches to all of their matches? So here's our problem again. We know that they play 14 matches home, 10 matches away. So the ratio of home matches to away matches is going to be 14 to 10. 14 home matches for every 10 matches away. But we know that 14 and 10 can both be divided by 2. So in lowest terms, the ratio of home matches to away matches is 7 to 5. Or for every 7 home matches, there are 5 away matches. Now the ratio of home matches to all of their matches means we have to do a little addition. So the total matches that the team played was 24. So the ratio of home matches to all matches is going to be 14 to 24. Remember, it's not 14 out of 24. This isn't like a fraction. And in lowest terms, we get 7 to 12. And we would say that 7 of every 12 matches that the team played was at home. So your guided practice question. Let's do this together. And it says that Derek and his brother decide to combine their CD collections. Derek has 44 CDs. His brother has 52. So in question A, go ahead and write the numbers down. What's the ratio of Derek's CDs to the number of CDs his brother has? And that's really not a hard question because it's just going to be 44 to 52. And then you're going to have to put that in lowest terms. Now the ratio of Derek's CDs to the total number of CDs is a little different. Derek still has 44 CDs, but you have to find the total number of CDs he and his brother have. So hit the pause button, solve the two problems, remember to put your answers in lowest terms, and when you're done, hit play to resume the lesson. Now we're going to talk about proportions. So proportions and ratios are kind of related in some ways. A proportion is just an equation that says that two ratios are equal to each other. This is a really important definition, so please make sure you have this vocabulary word in your notes. And again, you know this, I don't have to tell you, but anytime you need to, just hit the pause button, slow it down for a little bit, get the information that you need, and then move on to the next section. Now, other information you need to know about proportions. First, the denominator of the fractions or the ratios can't be 0. Okay, that's just not allowed. So for example, 3/4 and 6/8 form a proportion because 3/4 or 3 out of 4 is equal to 6 out of 8. So this is a proportion. The ratios are 3/4 or 3 to 4 and 6/8, and since they equal each other, then we would say it's a proportion. Now, how can we tell? Well, there's a simple test to tell whether two ratios form a proportion. And this is, again, one of those things that you probably already know, but we're going to review. When we have two ratios, and we want to test to see if they're a proportion, we can cross multiply. So 4 times 6 is equal to 24, and 3 times 8 is equal to 24. So when we multiply, cross multiply, and the products are equal to each other, these form a proportion. The other example shows that 3 times 5 is 15, 2 times 9 is going to be equal to 18, and since those two products aren't equal to each other, 18 is not the same as 15, then we would say it's not a proportion. So that's just a simple test to show that we have two equal ratios and whether or not we have proportions. And you're going to be using this quite a bit over the next couple of sections. So now, one of the other things about proportions is this. If we have one of the numbers missing, we can solve for the missing number with cross multiplication. So here's our first example. We've got the fraction or the ratio 11 to 6, and we want to know what that number would be if 30 was the denominator. What would the numerator be if the denominator is 30? Now there's other ways of solving this, but we're going to use cross multiplication for this one. So when we cross multiply, I'm going to use my mouse. 6 times x, we get 6x. And when we multiply 11 times 30, we get 330. And now we have a simple equation. So we know we're going to divide each side by 6. On the left-hand side, we're going to have x. And on the right-hand side, 330 divided by 6 is 55. So the correct answer here is 55. We always check. So we put the number back into the original equation. We already know that 11 times 30 is 330. When we multiply 6 times 55, we get 330 also. So since the two products are equal to each other, these two ratios form a proportion. So here's your next set of guided practice questions. Now, I know there are other ways of solving the proportions, but I'd like you to use, cross multiplication and cross products to find the answers to these. Take a second, copy these down, use cross multiplication, because again, in the next section, we're going to turn this up a little bit, and it's going to be not quite so easy, and it's not going to be all mental math. So please take a second, copy these down, hit pause, find the answers, and when you're ready to move on, hit play and resume the lesson. Okay, now, in real life, proportions are the kind of math that you will be using quite a bit of. So this is everyday math. Some of the math that we do, we're going to mostly see in a math class, or if you go into a career that involves like heavy-duty math, like what we're starting to get into. But proportions, oh boy, they're just like absolutely, positively the kind of math that we use on a daily basis. So our first application problem says this. A recipe to make salsa calls for 30 tomatoes to make 12 pints of salsa. The question is, if we want to make 4 pints of salsa, how many tomatoes are we going to need? Now, I want you to pay attention to the next slide because we're going to go through how to set up the proportion. And this is really, really important. So, we know that we need 30 tomatoes for 12 pints of salsa. And the question is asking us, how many tomatoes do we need for 4 pints? So notice what I've done here. We're going to combine or compare pints to pints. 4 pints to 12 pints. 12 pints of salsa need 30 tomatoes. You see that? We have that written right across there. 12 pints for 30. So we want to know 4 pints are going to cause, or we're going to require how many tomatoes. So we rewrite this as an equation. 12 times x makes 12x. We can drop the units. 4 times 30 makes 120. We know we're going to divide by 12, and our answer is going to be 10. When we check this, we put the numbers in. And we know that the answer is going to be 10 tomatoes. So, to make 4 pints of salsa, we need 10 tomatoes. And the key to this whole thing, the most important part of this whole entire thing, is understanding that we have to compare the same things to each other. Like pints to pints, tomatoes to tomatoes, and so on. There are other ways of writing it, but the comparisons have to be the same. So here's another one. Excuse me about that. I'll take a little break. So here's another problem. This time, it's asking us to find the amount of time it's going to take an elevator to get from the bottom to the top. Now, it's in a big building, and this thing moves pretty quick, 150 feet for every 5 seconds. It's telling us in this building that the observation deck, that means at the top of the building, it's at the 94th floor, which is 1,029 feet above the ground. And we need to know how long is it going to take the elevator to get from the bottom to the top. So there's a problem again. You see the calculator in the bottom right-hand corner. It means you should be using a calculator to do the math on this one. So look at what we have here. We're comparing the number of seconds to the number of feet. 5 seconds to go 150 feet. And on the other side, we're comparing how many seconds to go 1,029 feet. When we do the cross multiplication, 150 times x give us 150x, and 5 times 1,029, this is where your calculator comes in handy, although I've done the work for you, is 5,145. Now again, I wouldn't want you to spend your time doing this by hand. This is calculator math. So we divide both sides by 150, and rounded, we get 34.3, and that's in seconds because we were looking for time. So this elevator goes 150 feet in 5 seconds. It would go 1,029 feet in 34.3 seconds, and that's the answer to our problem. It'll take 34.3 seconds to go from the bottom to the observation deck, which is 1,029 feet above the ground. Now, we also could have found this information by making a table. So if you see what we did here, this is all in proportion. So this table is a really great resource to show you how proportions work. 5 seconds to go 150 feet, 10 seconds to go 300 feet, 50. Notice on the bottom, every time we go 5 seconds, we're going 150 feet higher. So this is in perfect proportion. And as we move out, we know that the elevator is going to go 1,029 feet. Well, that's really close to 35 seconds, which means our answer is going to be really, really close. And we know it's going to be 34.3 seconds. Okay? So more than one way of solving a problem. The proportions are the way that we're choosing. But again, making a table would have been another way to kind of at least gotten an accurate estimation of how many seconds it would take to get from the ground to the observation deck. That wraps up this lesson. So again, we're more than halfway through with chapter 3. The next section, we're going to go into proportions again, but the proportions you're going to see are going to be a little more challenging, but they're fun. So this is kind of, like I said, best chapter in the book for me for some reasons. Thanks for taking part in the project. If you get stuck on anything or you have any questions about the homeworks, please come and see me or ask a friend. Remember, this chapter goes up to 3.8, so we've got a little ways to go, but we're doing well. And again, please, if there's anything I can do to help you, don't sit and worry. Please just come up to me and we'll get everything straightened out for you. So thanks again. Get the work done for this section and then move on to section 3.6.